Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming.
Morning, everybody, and you're very welcome to this morning's Signpost webinar. And this morning we're joined by Dr. Karen Daly, Head of Environment, Soils and Land Use in Johnstown Castle, and by Dr. Patrícia Antunes, Research Officer in Water Quality in the Soils and Environment Land Use Department as well, supporting the Better Farm for Water campaign, and also Méabh. This morning's webinar is going to be on healthy soils, cleaner water, practical solutions from the Johnstown Castle Open Day. So we had a very enjoyable open day last week in Johnstown Castle, and Karen, I suppose that was an opportunity for the Johnstown Castle Research Centre to show all the science that they're doing around water quality and environment and biodiversity. And I suppose the recent opening of the new Nazarick labs in 2025 obviously is underpinning all that science.
Yeah, absolutely. We were delighted that Minister Hayden came down to Johnstown in November last, just gone, and officially opened our new facility. It's a new 2-story laboratory building that we managed to open with and get built with a 12.5 million budget. It's state-of-the-art laboratories primarily, and refurbished existing laboratories. So all of that facility supports the soil, water, gas, crop, bio-based fertilizers, slurry separation, all that kind of research that happens in Johnstown and across Teagasc. That facility can really help us drive on the innovation, and some of the work that was on display on the open day has come from that facility. So we were delighted to be up and running in the labs.
Very good, very good. And Patrícia, you're a research officer, but you did your PhD in Teagasc before you rejoined us.
So my initial training is in biology and ecology, but a few years ago now, I moved to Ireland to complete a PhD that was part of the Cusson project, which was actually, it was EPA funded, but it was led by Teagasc, and my role in it was to look at water quality and how it's impacted by direct livestock access to watercourses. After that, I moved to England and stopped doing research for a little while and just worked as part of the Rivers Trust movement. So I was project managing river restoration projects there in England for about 3 years. And then I decided I wanted to come back to Ireland. So I'm here now working as a research officer in water quality with Teagasc.
Brilliant. Well, without further ado, Karen, we'll hand over to yourself.
So we've divided this talk into 2 halves. I'm going to talk about healthy soils and soil health and what that is and what that means and what we can do to keep soils healthy. And then I'm going to hand over then to Patrícia to talk about the water quality side of it. These were the main themes of our open day last week. And we did showcase other technologies around gaseous emissions and biodiversity and manure separation and slurry management, etc. But we're focusing today's talk on the main themes of the open day itself. So what we kind of introduced to our visiting farmers and general public when they came into Johnstown Castle was we need to stay sustainable, but I suppose more often now we're looking at higher input costs, more volatile markets, changing weather patterns and more volatile climate. So the challenge of staying sustainable also means that we need to build resilience into our farm systems. So a lot of the technologies that we had on display, some of you may have seen and heard of them before. Some of them are existing technologies that go back a while. So, nutrient management planning, good use of lime on farm, putting clover into the sward mixes, and some of the new technologies around multi-species, carbon, building carbon in soils, and, looking at hedgerows and landscape features that can enhance biodiversity. We're all on display in the open day, and we try to focus a lot of the practical solutions around building resilience. So farming for soil health and the better farming for water, there are 2 initiatives in Teagasc that look at practical solutions for healthy soils and for water quality. And many of the measures that are derived for soils and for water and for gaseous emissions can have co-benefits across a number of different environmental metrics. So something, for example, a technology like liming soils or looking at optimizing your pH on soil. It's a technology that's been around for a good while, traditionally thought of in terms of balancing your soil fertility, optimizing soil fertility. But it's a technology that has multiple benefits across a number of different environmental metrics. So it's not only good for production, it's also good for savings on fertilizer use. So you're making nutrients more available in soil, which means that you're increasing and enhancing your soil health. It also, recent research in Johnstown Castle has shown that optimizing the pH in soil reduces gaseous emissions from soils. So there's another benefit there from the gaseous emission side. And on the water quality side, well, if you've got balanced soil fertility and you're watching how much phosphorus and nitrogen you're using, then you're also reducing the potential for losses to the environment. So there's win-wins across a lot of these technologies. And we've picked out a few there that cut across soil and water and gas. But we'll focus on some of the soil health aspects of the day itself. So when we talk about soils in agriculture, we tend to think of soils as, it's where we grow crops, it's where we animals graze. But really, the bigger picture on soils is that they sit at the intersection of food security, biodiversity, and climate, especially climate resilience. So soil health means that we're looking at what the soil does. What are the functions in soils? And these are the ecosystem services that we often speak about. So the ecosystem services that are primarily associated with healthy soils is food production. So they produce grass, they produce crops, and they produce fodder. So it's about that biomass production function. They store carbon. So they're one of the largest terrestrial stores of carbon on the planet. They also recycle nutrients. So they recycle phosphorus, nitrogen and sulfur and other elements, other major and micro elements in the soil. They also percolate water through the soil profile, so they have a infiltration function there. So when water percolates through the soil, they can remove contaminants. So having soils that have that function and have that function working well is always good. And also they provide a habitat for biodiversity. And the biology doesn't just live in the soil, they provide a regulating function. So the biology, the bacteria, the fungi, the fauna, they can regulate gaseous emissions, they can regulate nutrient cycling, and they can regulate the breakdown of organic matter and storage of carbon. So all together, it ensures food security. So healthy soils are about, food security, but also climate resilience, because once you have all of the functions working well, you increase your resilience to weather shocks. So if you've got periods of flooding and drought, if you have healthy soils, they can withstand some of the impacts of that. But when you have soils that are missing some of these ecosystem functions, you're going to lose maybe the capacity to grow enough grass, and you might lose the capacity then to resist periods of floods and heavy rainfall. And all of these connected events kind of feed into each other. So loss of productivity means less carbon stored. If you have compacted soils, you might be looking at flood risk, and you're changing the structure and community structure of the biology in the soil. So you might be losing some of that regulating function in soils. So globally, we're very interested in healthy soils. And the EU, the JRC in the EU has estimated that 60% of soils across the EU, based on their Lucas surveys, are degraded. And they've estimated that it costs us a lot of money every year when we have less productivity and less ecosystem function. So in Ireland, we're looking at assessing our soil health, and we have put together the principles of soil health. And we put this on display at our open day last week. Within our booklet here, Farming for Soil Health, in the bottom left-hand corner, you'll see a QR code, and you can look at that publication on our Teagasc website. And that publication outlines the practical solutions for keeping soils healthy, but also the main principles of what you need to look for. And this is what we'll kind of go through this morning. So the 6 principles are all outlined there. And, the use of local knowledge of soils is extremely important. And it's not just important for soils, it's important for water quality. And Patrícia will touch on that when I hand over to Patrícia later on. So knowing the soils around your farm, knowing the kind of soils in your locality. We have some visual tools for assessing soil health. We have ideas and tips for avoiding physical damage and what physical damage might look like. We've got tips for looking at how you can improve and enhance the soil biology and soil biodiversity, and what you can do to build organic matter and keep your soil fertility balanced. So in terms of knowing your soil, well, the main aspect of soils that you need to know about is the texture, and because texture informs structure, and the structure in your soil can influence how soils drain water, how they retain nutrients, and how they can maybe resist compaction or are at risk of compaction. So the triangle in the center there outlines the kind of main texture classes, and you may be familiar with terms like silty clay loam, sandy loam, but the three main elements of texture are sand, silt, and clay. And if you have parts of the farm that are heavy soils, these are soils that have high clay content. And if you have light or well-drained, free-draining soils, these are soils that have more sand in them. So they might be sandy soils or sandy clay loam soils. Loamy soils are a happy medium in between the two extremes. So they all have different ways of resisting compaction, filtering water, draining water, holding and retaining nutrients. And so your texture and your structure can inform how you might manage your soils. So if you know and understand what parts of your farm have heavy soils or high clay soils, sandy soils, you might be able to adjust your management practices on those soils to avoid compaction and avoid maybe, I suppose you want to keep the water flowing through the soils, percolating through the soils. You want to avoid waterlogging, etc. So local knowledge of field characteristics. Have you drained the fields in the past? Are there ditches around the perimeter of the field and the field boundaries? What are the past management practices? Because they will all inform how healthy the soils are. And what the type of soils in your area will be available online on our national map. So the soil information system is our main national map there. And you can look in to where you are and the soils in your area. But really locally, knowing the soils around your farm is probably the best way to go. And if you're a soil surveyor, you'd be looking for things like soils with thick organic layers, soils that are shallow and gravelly, soils influenced by water, soils that might have, leaching of iron and aluminium. So that's when you have podzols in the landscape where nutrients might leach through. Soils that are with a clay-enriched subsoil. So these have a sort of a deep pan of clay and subsoil, and you might get a groundwater glaze. So there's a bit of water element to that. And then young soils with little development. So these are the type of diagnostic features that informed how we surveyed our soils at a national scale and then mapped them. But how you might assess your soil health yourself on your farm or in your area, there's a lot of visual tools that we have, and a lot of them are laid out in the booklet that I just mentioned earlier. So, there's some images there of typical soil profiles. These are the main soil groups that we would have in agriculture in Ireland. So we have brown earths, which are very kind of good free draining soils with a nice mix of clay, sand and silt. So they're good loamy soils as well. We've water glaze, so there's surface water glaze and groundwater glaze. These can often get waterlogged and can be prone to compaction as well because of their lack of infiltration capacity, and that's just how they're made up. So again, if you know that you have heavy soils around the farm, you might kind of look at how you might manage those more efficiently and more effectively in terms of making them a little bit more resistant to compaction. And there's blanket peats and alluvisols as well. So histic soils are usually soils with a sort of a peaty top, peaty first horizon, and then a more mineral enriched and mineral soil underneath. So the functions that we want to look for: plant productivity, how they store carbon, does water percolate through the soils, are they retaining nutrients or leaching nutrients, are they resisting compaction? They're the type of indicators you might look for, and the type of vulnerabilities. And some of the visual clues there are the soils kind of aggregated. If you look at some of the topsoil, does it look like clumps and aggregates of soil? That indicates good soil structure. Can you see roots and deep root growth? Is there evidence of earthworms and fauna? Can you see a sort of a darker colour indicates good organic matter, and you might see pockets or little tiny air holes. That's where you'll see a lot of the biology living. And then poor soil health indicators. Well, if you've got kind of compacted soils, you might see that visually at the surface, but you might see it also slightly underneath if you have mottles of iron redox, or you might see some cracks at the surface where it's dried out, and you can see kind of deeper down where it might be compacted in the plough pan. And that, poor soil structure there is going to limit the amount of water percolation through the soil. So avoiding physical damage then, I suppose it's a common problem on many Irish soils. By and large, we do have good soil health in Ireland, but the one thing that we do want to watch for is compaction. So avoiding physical damage, because we have parts of the country that get more rainfall than others. So avoiding trafficking when soils are too moist. So looking at the Méabh indicators of soil moisture deficit, looking at the weather patterns there. So what happens when you compact soil is that the machinery might move across the surface, but you'll see the compaction happen in the subsoil layer. So it happens deeper into the soils, and it's often difficult to fix. So prevention is probably the better cure really here, before you have to sort of intervene and do something like mechanical subsoiling to try and release some of that subsoil compacted layers. So again, it's about preventing compaction. So aim to sort of travel and use machinery when soils are dry enough, and the Méabh guides are a good guide to that. And again, compaction is one of those aspects of soils that it can impact on a lot of ecosystem services. So you might lose some of the pockets of air where the biology lives. So you might lose some of your biological functions. We know that there's less production, so less crop growth. Crop yields are lower on compacted soils. And then you're losing the water infiltration capacity, opening yourself up for risk of nutrient and sediment loss. So these are the things that have the knock-on effects of having compacted soils. Supporting the soil biology is the fourth principle. And what we want to do here is just make sure that we keep the soil biology in good shape. We want to, you might be able to recognize some of the species in your soils if you go looking. Obviously, some of the key kind of messages here are around, overuse of chemical fertilizer, overuse of chemical inputs. Try and prioritize organic manures and organic fertilizers. And keep the habitat going, keep good organic matter in the soil. So look out for the colour of your soils as well. That's an indicator of good organic matter levels. And then on to organic matter itself. So organic matter is like the glue in the soil. If you've got good dark coloured soil, you'll have good amounts of organic matter. It's an easy test to do. So if you were testing your soil, you can get it tested for percentage organic matter. And most Irish soils have good amounts of organic matter, largely derived from, we've temperate climate. Other soils around Europe that have drier climates will have less organic matter. So on the European scale, we're doing quite good there. So we want to keep that up. Organic matter breaks down and stores carbon in soil. So it's something that we want to keep going in the soils. And again, it provides structure. So the more organic matter you have, or if you have the organic matter you should have for the soil type you have, it keeps the structure intact. And keeping the structure intact then makes sure that you're keeping water moving through the soil, percolating, you're avoiding any kind of, waterlogging situation or compaction. So cover crops, natural regeneration, they're good ideas for building organic matter. Grass clover, multi-species swards, keeping a good balanced soil fertility as well. If you're a tillage system, incorporating straw or crop residues into your soils, minimizing physical disturbance, again, with machinery, going out, watching the weather, because compacted soils, you might be compacting everything down there and you might lose some organic matter. So balanced fertility is the last of the principles. And again, tried and tested, we know all about why we need to have optimum pH, optimum P's and K's. They're good for growing crops, they're good for animal health, but they also are good for soil health. So when you keep everything in balance, you keep the biology in balance. And again, local knowledge is key here, knowing what parts of the farm might have less or more phosphorus or potassium. So getting regular soil tests, or get your soils tested on parts of the farm that you're unsure of. So sometimes some parts of the farm might be easier to access, so you end up having high levels of phosphorus, but you might have lower levels of phosphorus around the farm. So a good distribution of P's and K's around the farm is good. And again, like I said earlier, lime requirement, it's a technology that's been around for a while, but it hits a number of ecosystem functions and ecosystem services in soils. So prioritize these practices to try and get your soil fertility in balance. A lot of these resources are available on our Teagasc website, and the QR code there will take you directly to the Farming for Soil Health best practices for managing Irish agricultural soil. So all the principles, all the practices, all the tips. We have a lot of video content on the Teagasc YouTube channel in both Irish and English. So there's a lot of visual stuff that you can do. You can learn how to visually assess your soils, and you can look at some of the tips that I just walked through there with around the 6 principles. And with that, I'm going to hand you over now to Patricia, and I'll stop sharing.
Thanks, Karen. So I'm Patrícia Antunes, and I will talk about the water quality information that we talked about in the open day just a couple of weeks ago. So just an overview of water quality in Ireland. So the last report that EPA published, referring to the monitoring period of 2019 to 2024, indicated that almost half of the water courses, the surface water bodies in Ireland, were in unsatisfactory status, and that means that they were in lower than high or good status, which is what we need to achieve as part of the Water Framework Directive. And the EPA also reported that one of the main pressures on water bodies is nutrient pollution. It's that first item in there in that graph. And within nutrient pollution, we have nitrogen and phosphorus pollution. As you can see from those two graphs on the bottom, nitrogen, a large proportion of it is arising from agricultural activities. So the green and the yellow indicate grassland and arable sectors, and that's contributing nitrogen to waters. Phosphorus, a proportion of it also comes from agriculture, although we also have some contributions from wastewater. In the most recent report that the EPA published looking at the year of 2025, it stated that across the country, nutrient levels are too high still in many places. A large proportion of river sites have high nitrogen levels, and these tend to be in the east and south of the country. And we also have a significant proportion of rivers and lakes with too much phosphorus. And this is a problem because it impacts on rivers and streams in the aquatic ecosystems, but it also impacts our estuaries and coastal waters because these nutrients would be transported to these systems, and there they can affect the ecosystem as well. So it's important that we try and improve water quality as much as we can to protect both inland waters and our coastal waters. So in agricultural land, in terms of nutrient losses, nitrogen, phosphorus, and sediments, the mechanisms through which these losses happen can be quite complex, but broadly speaking, phosphorus is an element that interacts very strongly with soil particles, in particular clay particles, and so it can accumulate in the soils over time. And in areas where the drainage is not very good, so in poorly drained soils, what tends to happen is that when it rains, the water is not drained and it forms overland runoff pathways. And as the water travels across the fields, it will collect sediment particles and phosphorus particles with it, and these will then be transported to water courses. Nitrogen, on the other hand, it has many forms, but nitrate, for example, is very, very soluble. So it's easily transported with water. And in well-drained soils, when it rains, this water percolates through the soil profile, and it takes this nitrate with it. So the nitrate travels across the soil and it can reach groundwater bodies and then eventually reach surface water bodies. So I'm going to start by focusing on nitrogen. So nitrogen in soils, as I said, takes many forms, but nitrate and ammonium are those that are directly available for plants to use. And in farmland, the sources of these two forms of nitrogen tend to be chemical fertilizers, organic fertilizers, livestock urine patches, which are highly concentrated because the animals will excrete nitrogen in the urine, which will be deposited in a very small area. So it would be very concentrated, way over what plants can consume. And so it's very prone to be washed. Excuse me. And then we also have mineralization of organic N in soils. And this is something that is favored by plowing, because when soils are plowed, organic residues in the soil are exposed to microbial activity. And plowing also introduces oxygen in the soils, which then also favors microbial activity to degrade these organic residues and release nitrate and ammonium into the soils. So as I said, these two forms of nitrogen are very prone to being washed away. And so one of the most effective ways of trying to mitigate these losses is through managing the source. So that means tackling what goes into the system. And often it means reducing nitrogen surplus and increasing nitrogen use efficiency, they go hand in hand with each other. And so when we're looking at nutrient management on farm, it's important to apply the 5R principle, which means using the right product at the right time, in the right place, apply the right rate, and use the right method. And so I'll go into that in a little bit more detail. Just next slide. So what measures can farmers implement to improve crop uptake and reduce losses of nitrogen on farm? So we can start by trying and reduce nitrogen surplus. So that means reducing inputs of chemical nitrogen, match fertilizer inputs to the need of the crop. So that little R there indicates that we're looking at one of the 5R. So that would be right rate, for example. Make use of precision and management technology, for example, the use of GPS and yield maps, so you can apply your resources where they are most needed. If you have grassland and you have clover in your sward, or apply organic manures, reduce chemical and input accordingly. If you have livestock, reduce concentrate feed use and reduce crude protein content in the concentrate feed, because this contains nitrogen that would then be excreted by animals. Then the next approach would be improve nitrogen use efficiency. So for this, we can look at ensuring soil health, and ensure that we have the correct pH and the correct nutrient balance, so the correct levels of phosphorus and potassium, so that the availability of nitrogen to the crops is maximized and it's taken up by the plants as much as possible, because these factors will ensure that everything is in the right balance in the soil, so that the right chemical reactions can take place and plants can incorporate the nitrogen in their biomass. The same is true for sulfur. If you have soils that are sulfur deficient, that will interfere with the ability of plants to take up nitrogen. So it's important that you have soils with the correct amount of sulfur. So as I said, these chemical reactions can take place and nitrogen can be taken in and transformed into plant biomass. And finally, we can target nitrogen mobilization. So one very important thing to do is to only apply fertilizer under the right conditions and in the right time. So that has to do with, for example, the close period. When we have high rainfall and we have low temperatures, crops are not growing, and so they're not utilizing the nutrients in the soil. So it's important to avoid those conditions when applying fertilizers. Outside of the close period, we can also have days where the weather conditions are not favorable for plants to take up the nutrients, or they are favorable for the nutrients to be washed away. So we don't want to waste the resources. We don't want water quality to be impacted. So we want to avoid and spread on these times. Another thing is to use protected urea, because urea will be converted to ammonium, not nitrate. And so ammonium is more stable in soils than nitrate because it reacts more with soil particles, so it's a little less prone to being washed away. And protected urea contains an inhibitor that will make urea be converted to ammonium slower, and so that makes sure that the nutrients are not washed away after you apply them and they don't get used by the plants. So in this way, you can prevent some of those losses from happening. And finally, you can plant cover crops over winter. Cover crops will take up the residual N that is left in the soils over winter, and they will also create a cover in the soil, so soils are also less prone to erosion. So in terms of taking action directly in your farm, so the first thing to do is to use local knowledge to get to know what's happening in your farm. So there are a lot of resources available online, freely and publicly available. So for example, if you have a watercourse in your farm, you can access EPA maps to see what's the water quality like in that watercourse. And then we also have pollution impact potential maps for nitrogen and phosphorus. So for example, this PPEN map, it will show what land is more prone to nitrogen losses because of the soil characteristics and so on. So you can log in or access the website and see how your land is scoring like in terms of nitrogen loss risks. Also, as Karen mentioned, you can look at the National Soil Map of Ireland and see what type of soils do you have in your farm. Also the best thing to do as well is to go out and look at your soil in different parts of your farm, look at the texture, look at how is it looking like, how healthy it looks, and have a good understanding of where you might have areas in the farm that the soil maybe is not as healthy, and you might want to take different actions in different parts. There are also many tools out there available to help you with improving your nitrogen use efficiency, for example, and mitigate losses. So we can talk about AgNav, which is a tool from Teagasc and partners that allows farmers to look at their emission figures and allows them to see what would change in terms of emissions if farmers change their practices. So this helps with emissions for climate change, but it also obviously works with water quality because we're talking about a system that functions all together, and nitrogen. You can also look at pasture base, which helps with managing grass production for grassland farmers. It helps you calculate your nitrogen use efficiency. The Grass 10 newsletter also provides information of forecasted grass growth, so you can match your fertilizer use to the grass growth. And you have nutrient management plans online, which help you plan your nutrient use in your farm. Next, you can also talk to your farm advisor and discuss exactly what actions you could take in your farm to help mitigate nitrogen losses, what works for you, what works for your soils, your farm. ASAP advisors, they're specifically trying to help with water quality. And also the Better Farming for Water campaign publishes a lot of resources to help with mitigating nutrient losses to waters and what actions work best and when they're best applied. So it's worth keeping an eye out for that. Now moving on to phosphorus and sediments. So as I said earlier, phosphorus has a high affinity for soil particles, so it can accumulate in soils, but when it's lost, it's often through overland runoff in association with sediments. Once in water bodies, phosphorus is very difficult to control because it can also accumulate in the sediments in rivers and streams and lakes, and it can be released again back to the water quality if the chemical conditions, for example, favor this reaction. So that means that we can have sediments acting as sources of P as well to waters, P that has come from the land and that has ended up in the water. It can still contribute to the water levels of phosphorus. So that means that it's very important to prevent this from happening in the first place and try and reduce P losses from land as much as possible. So some risk factors for pea and sediment losses from agricultural land and overland runoff formation is to have, first of all, soils that are high in P, then naturally impermeable soils or soils that are bare, trampled, or compacted, which will be more prone to erosion, will be more prone to overland runoff formation. Steep slopes also help with this. And then if you have, for example, open drainage ditches which receive diffuse runoff from the farm and then are connected to or leading to watercourses, that's a way that sediment and phosphorus can reach these systems as well. And if you have poorly designed or sited farm roadways, they will, for example, have traffic of animals. They will accumulate sediment, feces and urine from the cattle, and they can be impermeable, so they will collect its runoff and can then direct it to watercourses. So in terms of controlling phosphorus and sediment losses, it's important to look at break the pathway measures. So we're trying to intercept these overland runoff pathways and prevent it from reaching the watercourses. So we can implement field and edge of field measures. So that can be, for example, riparian management measures, linear margins, or better still, spatially targeted riparian buffers. You can also look at interception ponds and wetlands, bunds or berms, hedges, mounded or without a mound. Cover crops would also help stabilizing the soils and act as a barrier for water movement, so that can help with these losses. Excluding livestock from watercourses is also important because they can really cause a lot of damage by accessing the watercourse and then defecating and urinating directly in the water. And again, applying fertilizers only in the right time and the right conditions. In terms of managing drain ditches and roadways, we can look at measures such as settlement banks, willow beds to filter the drainage effluent, also retention barriers. They can be very simple. For example, we can have bunds within drains, or we can have a leaky dam, such as in the third picture there, that will trap sediments and the associated phosphorus that is traveling in these drains. And for roadways, we can implement water bars, for example, to intercept runoff, and the runoff can then be, for example, diverted into areas in the farm that will allow this runoff to infiltrate into the soil and so prevent the runoff pathways from washing away into the watercourses. In terms of taking direct action in your farm, again, use local knowledge and all the information that is available online to really understand what's going on in your land. So again, you can look at the watercourse maps and the soil type maps to help you have a good idea of what you have in there. You also have the pollution impact potential maps for phosphorus that will show you which land is more prone to phosphorus losses. And for phosphorus, you also have maps that show where runoff pathways are more likely to form and where they are more likely to deliver this pollution to the watercourses. So you can use that to help you target any mitigation measures. Then the best thing to do would be to look along your farm after rainfall, see where you see overland runoff forming, where do you see it accumulating, where do you see it reaching the stream, and those would be all great places for you to try and implement measures that work for you to intercept that runoff. And so then you can discuss with your farm advisor to get some support, and then implement the measures, break the pathway measures that best suit you and your farm and the conditions that you see in your farm, the pathways that you find in your farm, and remember to apply the right measure in the right place. So again, the right measure tackling these pathways that you have identified and tackling the problem that you have identified in your farm. So in terms of take-home messages, so as I described, nitrogen, phosphorus, and sediments, they behave very differently in the landscape, so they will need to be tackled in different ways. And often you'll have to look at a stack of measures to target different things in different places. And it's a matter of looking at what works for you. So know your farm landscape, make use of the resources out there available, know your soils, know how they respond to nitrogen inputs, identify where phosphorus and sediments might be being lost from your land, and target the specific issues that you identify. So take actions to reduce nitrogen sources, implement break the pathway measures for phosphorus and sediments, make use of the available tools out there again, and make use of advisory services for support, and remember the 5 R's. Also, again, keep an eye out for the 8 actions for change that are part of the Better Farming for Water campaign, which really they go through all this that I mentioned, and there will be a lot of information resources out there to guide and to help making decisions. So keep an eye out for that. And that's all for me. Our Open Day booklet is available in our Teagasc website at that link. All the information that was presented in the Open Day, including all the information that myself and Karen presented today, is there. So you can download that in PDF form from the website. Thank you.
Great, Tricia and Karen, thanks very much. And excellent presentations from the two of you, and you covered a lot in it. And I suppose the thought struck me, Karen, as you were going through yours. You know, we're very much focused on what we can see on our farms from a biodiversity or water or climate, and we forget the importance of what we're walking on.
Yeah.
And you know, so sorry, go on.
So like the main messages that we really wanted people to take home with them, apart from the sort of specific actions, was that kind of local knowledge is really important, because if you know your soils, it helps you to manage them in a way that improves water quality, enhances biodiversity. So there's lots of kind of knock-on effects on good soil management. And I think we do tend to sort of go for the big landscape features like the hedgerows, as they say, and looking for, you know, cattle exclusion zones and buffer strips and all the kind of things that you can kind of visually see across the landscape. But right underneath your feet is probably the most important resource on the farm. So soil is a very important resource on the farm. And there are things that you can do that, you know, don't cost a huge amount of money, with a little bit of local knowledge or using soil maps and resources. You can just tweak your management of soils so that you keep them healthy. And once you keep soils healthy, you're building in some resilience into your farm system. And, you know, you're kind of hopefully then when we have kind of extreme weather events, you know, intense rainfall events, your soils are better able to cope with that. You know, so that's kind of the main message that we wanted people to go away with.
Yeah, and I think, you know, the roles of the functions that like it's obviously helps to produce your grass or your crops, but the other roles, the environmental roles, I think were, you know, maybe are underappreciated. Yeah,
absolutely. And I suppose traditionally in agriculture, we've always thought of them as, you know, we just need to make sure we have all the right nutrients and micronutrients in place. But what's going on underneath and inside the soil as well in terms of the biology, that, you know, a lot of new research is coming through in the last decade of the importance of soil biology. And it regulates, the biology is there to regulate how it breaks down organic matter, stores it as carbon, how it breaks down organic matter and makes all the phosphorus and sulfur and nitrogen available. And then the latest research from Johnstown showing that if you can optimize your pH, the biology will kick in and try and will reduce gaseous emissions. So the biology is really important in the soils, a little bit underappreciated because we can't really see it with our eyes, but it's doing stuff in the soil. So keeping your soils, you know, free from compaction, keeping balanced soil fertility, keeps the biology in good shape and keeps it regulating all those functions that we need them to do.
We've like Teagasc obviously does a lot of open days, but one of the biggest draws at any open day is when we have a hole in the ground.
Yes,
we have one of our soil scientists in that said hole explaining what you're looking at.
What you're looking at, exactly. And there's no better way to explain soil than to open up a pit and be able to sort of show people where the first horizon starts and ends, and where you're looking at, where you can see changes in colour as you look down the profile, and you'll see a change in colour and sometimes a change in structure. And when you can open up a pit and show people how deep the roots can go, and where you're going to see, you might see little orange speckles that's kind of mottling of iron and stuff like that. So they're all clues as to what the soil is and how healthy it is. And it does draw a crowd. So once you dig a hole and put someone in it, you're guaranteed to get a crowd gathering around. So yeah, that's the best way to soil science.
Very good. Yeah, Maeve, do you want to come in there with a couple of questions?
Yeah, but even just coming back to like what you were saying, Noel, about, how sometimes we can forget the importance of what's underneath our feet. I think it was actually Cathal Summers that was, out at a farm event with me once, and he said you cannot underestimate like the importance of just having a spade in the cab of the tractor or the back of the Jeep or whatever, and just getting out in the field and putting the spade into the ground and turning up a sod and looking at what's actually happening underneath the surface. And it kind of actually ties in with a question that we have coming in there, assessing what the soil structure is like even in that top layer, and looking at whether there is kind of impacts of compaction within that top layer. And I might just ask you, Karen, there was a question there to kind of actually explain, what is soil compaction in terms of like what impact does it actually have on the soil? What are the negative effects of that, I guess, from a soil health point of view? If you could just maybe give us a little bit of detail on that.
So that's probably the one aspect of soil health that we in Ireland do need to look more carefully at. I mean, we generally, compared to say some of our member states across Europe, we have good soils. We have really good, healthy soils in Ireland, because we're a temperate climate. But we do have soils, and because I suppose we have some heavy soils around the country and high rainfall in parts of the country where people need to still get out with machinery and still put animals out, it does compact the soils. So that's the one aspect of soils, and we feature that quite strongly in the Farming for Soil Health booklet. So there's a section there on what to look for. So when you compact the soil, you're basically squishing it down, and sometimes, like you say, that kind of spade method where you're just digging up maybe a little bit, a bit of a square on the surface, you'll be able to see if you have good, crumbly structure. So if your soil crumbles quite readily in your hands and you can see clumps and aggregates, that's good. But if your soil doesn't crumble quite easily, it might show signs of compaction there. Generally speaking, we see compaction a little bit deeper down, so the impact happens a little bit underneath the surface, but you can still dig down and see it, and you'll see that pan of compacted soil, but you're squashing the soil, so you're removing some of the air pore space in the soil, which is where the biology lives. So you might be losing some of the biological functions there, or limiting their biological functions. Also, water, when water just doesn't just move across the surface. There are subsurface pathways in the soils. So you could be then opening up yourself to being at risk of generating more overland flow. You reduce the infiltration capacity of the soil, so you might have a knock-on effect on water quality there. The other thing as well, there was a study a few years ago here in Johnstown with colleagues in crops department in Oak Park, and they showed that there was 20% less productivity on compacted plots when they were growing cereals. So again, there's a you're going to be losing out on production as well. And again, like the biodiversity, you'll be changing the structure communities of your biology in the soils when you're removing that pore space. So compaction is one of those things that it has an impact across carbon storage, nutrient cycling, productivity, water infiltration. So it knocks out a number of ecosystem services and functions. And there are some very handy tips in the booklet, and they were on display at the open day, and we actually had a compaction pit as well. We had 2 pits open on the day. We had an example of what you can see, that compacted pan in the subsurface layer. But again, like you say, a spade, dig it up. If it crumbles nice and readily, it's good. But if you can see signs of compaction and just squish down, it might be a little bit compacted. And
It
prevention.
seems to be, yeah, it seems to be really a trend in both your presentation and Patricia's presentation, as well as like how you can connect the dots that everything that impacts soil then has a knock-on effect further down the line, whether it's from productivity, whether it's from nutrient loss or whatever. Like it's all connected. And you mentioned there about biodiversity and microorganisms. There's a lot of questions coming in then about ways to improve biological activity. Questions around applying microorganisms to the soil or whatever. So can you just comment on what's some of the best ways to improve microorganism activity within the soil?
So keeping your organic matter levels good and healthy is probably the best thing you can do. There are probably products out there to put on the soil that claim to improve the biology and microbiology in the soil. There's limited amount of research on those, so I'd say the jury is out on whether they're uniformly effective across all soil types. But the best thing you can do is, prioritize using your organic manures. If you're a tillage system, incorporating straw back into the soil, and keeping your organic matter cover crops. If like bare soil might lose organic matter if there's extreme weather conditions. So cover crops and obviously multi-species swards are good for building organic matter because they've got deep-rooted systems. So there's a lot of management practices that you can take on that will build organic matter in soil before you need to, think about buying products. And we don't have a huge amount of research to back up some of those.
Very good. I might just ask Patricia there, from your point of view, there was a question that's after coming in around drains. Farm drains. I know, Karen, you can probably come in on this one as well, but for Patricia, the first thing it says about streams, but you can't drain streams, you can't touch streams. But from a drainage point of view, have you any advice to farmers? Because I suppose you mentioned about phosphorus and sediment leaving the farm, and obviously there has to be a pathway for that to get into the streams that are causing the damage, and farm drains are one obvious pathway where that happens. So have you advice for farmers out there who have a network of drains and other farmers that may be thinking, I need to install drains, on how they should go about it to minimize the impact on water quality?
So if we're talking about, for example, drain ditches, the ones that will collect what's coming from the field and transport it, I'd say anything that traps sediment is a good thing. Anything that slows the flow of water in terms of enhancing the reactions that take place, in terms of getting some of the sediment in the water to settle within the channel. Those are things that will prevent these sediment and then the associated phosphorus to go to end up in a water course. So for example, you can some of the measures that are out there that are available with schemes for farmers to apply for are that type of measures. For example, settlement tanks or filter beds, willow beds that you can have that your drainage will go through before it travels further in the drain. That's specifically looking at farmyard, for example, farmyard drains. But you can also install the type of things like bunds in your drain. You can have the leaky dams, for example, there's just barriers that slow the water flow and trap that sediment behind it. If you have vegetation, that vegetation will also filter some of the sediments. Vegetation will consume some of the nutrients. You might want to manage it so it doesn't get a lot of out of control and the vegetation doesn't die and then kind of releases all those nutrients back. But that sort of those physical elements that trap that sediment, trap that phosphate, and then create time for biogeochemical processing to happening will help with those losses.
Yeah, and I suppose that obviously the purpose of the drains is to get water off the farm, off the lands, but you have an extra day's production and that kind of thing. But it is a double-edged sword from the point of view of also transmitting that sediment and phosphorus. Karen, did you want to come in on that and say anything on that?
Yeah.
I'm sure you've done a lot of work on that before.
Yeah, we've done a few studies on farm drains, open ditches. There's a multitude of names for these things across the country. People have different names for ditches and drains, but where the connectivity is essential. So if you get a chance to map what you have on the farm, so if you know where the drain starts, where the drain ends, is it connecting to a stream, or is it just going off into another drain? So, that we had a study a few years ago where we kind of had a category of different types of drains. So you want to look, your high risk is where you might put your measure in if you're putting in a barrier measure. So if you have a drain that happens to kind of connect into a small stream or go off the farm into a small stream, that's probably the first place you might look at, trying to avoid any sediment moving into that stream. There's a lot of drains that, they might be at the edge of the field boundaries, and they mightn't go anywhere. They might kind of, they'll receive water coming off the field, off the surface and subsurface pathways. They might go into another drain and then disappear off through the landscape. But it's the ones that it's the connectivity. What are they connected to? And if you can identify what it's connected to, then you can look at maybe installing a very, very cheap, very effective barrier. It could be anything like the little wooden leaky dams that Patricia showed there, or bunds, or vegetation. Anything that slows the flow of water down will just let the sediment settle down, and you avoid then nutrients moving off as well.
Very good. Méabh, have you any further questions there?
Yeah, just a very quick question there, as I know we're running out of time. But Patrícia, just in terms of, you talked a lot about, nutrient losses and stuff like that. But just if you want to maybe give us a quick comment on the importance of soil sampling for farmers, how often it should be done, and the importance in I guess managing those nutrient losses from the farm.
So sampling your soil for nutrients and for the other parameters that Karen mentioned there is important to know what we have and how we might manage the soils then. So this is particularly important, for example, in the case of phosphorus, because you will need to know how much phosphorus you have, where does that fall in terms of the 4 indexes, and then from that you will manage your soils and apply your fertilizer depending on what you have. And that will help you reduce losses and save money, because you don't want to apply fertilizer where you don't need it. So it's important to have that knowledge. The frequency, I think you might do it every year, but Noel might have more details on that. But I think if you have a nutrient management plan, you will do it at a certain frequency anyway that you have to do it. But the more you know about your soils, the best. And was that another part of the question? Sorry. How you might manage.
Well, just in terms of, reducing nutrient loss, the importance of having your soil samples done.
Yeah, so it's important for you to know what you have there in terms of nutrients. So nitrogen is more difficult to know what you have from a soil point of view, but phosphate, you should definitely test it, and for the other nutrients and pH, so you can adjust these accordingly to make your soil as healthy as possible. And also, as you're sampling your soil, you have a look to see the texture and all of that. So it's really to know what you're working with and use that then in your decision making.
Perfect. Yeah.
Okay, we're running out of time, or did you want to ask another, Méabh, or we leave it at that?
Well, just on it, there was just a question on how long the soil samples last. So I know, if you're really up to date with managing nutrients and stuff like that, some people would be testing every 2 years to really keep on top of their nutrients. But from a requirement point of view, I think it's every 4 years. Is that right, Noel?
Yeah.
So just and that would a lot of people would be kind of falling into that bracket now, that they'd need to be getting their soil samples done every 4 years. So
exactly. Look, unfortunately, time has caught up on us. That hour went very, very fast, which is always a good sign. And I think, Karen, you're going to have to come back and do a full webinar on compaction and soil health, because there's an amount of questions coming in, big interest in it, and maybe even an open day or something on it, because it really has exercised the people online.
Right.
Look, can I thank both yourself, Karen, and Patrícia and Méabh for coming on this morning and doing such a good job on the presentation. I want to thank you, the listeners, as well, for joining us every morning. You're a very loyal bunch. You know, great numbers again this morning. So we really appreciate you taking the time of your week to join us on the webinar. Next week, we have invasive alien species. The biological kind, no, not the extraterrestrial kind, but invasive alien species, practical solutions from Acres CP, and we have Kate Moore from the Acres there to come and talk to us about that. So look, that should be very interesting, and is a big problem in certain parts of the country, and there are some fantastic things going on by the Acres CP teams to alleviate those. So I think I'd encourage everybody to try and join that call or that webinar next week. So look, just thanks again to everybody, and to Cian Condon and Mark Gibson, who are keeping the show on the road with this with regards to the webinar. And listen, everybody, have a lovely day and have a nice weekend.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.